Hi, today we're gonna be solving exercise 28 of the project, which is from the book that we're gonna be solving this year. So the exercise 28 says tangent square of x by cosine square of x plus cosine square of x is gonna be equal to 1 over cosecant square of x plus 1 over secant square of x. So right off the bat, right here, we can see that these are reciprocal identities. Which reciprocal identities? If you check on internet or in your notebook, you can see that this is equal to sine square of x plus this is gonna be equal to cosine square of x. And then next step, we wanna change the tangent to terms of sine and cosine. So it is a tangent square of x, so sine square of x over cosine square of x times cosine square of x. This is a fraction, so we're gonna be putting the one right down here plus cosine square of x. So the numerator by the numerator sine square of x times cosine square of x over cosine square of x times 1 is gonna be cosine square of x plus cosine square of x. Sine square of x and cosine square of x. So we can see that if you divide these two, it's gonna be equal to 0. So we check them out right there. Sine square of x plus cosine square of x, sine square of x, and cosine square of x. So we're gonna be solving another trigonometrical identity demonstration as the past video of exercise 28. This time is gonna be exercise 29, which states that cosecant of minus y over secant of minus y, it's gonna be equal to cotangent of y. So we can see that this is a reciprocal. Its reciprocal is gonna be 1 over tangent. 1 over tangent. But this can also be seen as cosine over sine of y and of y. Cosecant of minus y, it's gonna be have the reciprocal of 1 over sine of minus y, and over secant, which its reciprocal is gonna be 1 over cosine of minus y. So we're gonna be applying a procedure called the sandwich law, which involves all the denominators and the numerators. So we're gonna be multiplying this denominator by this numerator, and it's gonna go underneath of the division. So sine of minus y over 1 times 1, it's gonna be sine of minus y. 1 times cosine of minus y, it's gonna be cosine of minus y, equal to cosine of y and sine of y. And right off the bat, right here, we can see that this is a false trigonometrical identity demonstration. Shows us that this is a wrong statement.
Hi, so now we have to solve problem 1. Actually, we need to check that this is the right answer for this operation. So where do we start? First, we need to transform everything into sines by applying this trigonometric identity. That says the cosecant of theta equals 1 divided by the sine of theta. After we've done that, we will get this. Then we will have to answer the addition that is at the bottom, and it would leave us with sine of x plus 1 at the top and sine of x at the bottom. Then we write everything down again because we do not want to get confused. So now what we need to do is to solve this division. So at the bottom we start with the ones that are outside. So it will leave us with sine of x multiplied by 1 at the top. And at the bottom with sine of x multiplied by sine of x plus 1. We cancel sine of x at the bottom and at the top. And write the other part of the problem. After that, we will have to answer this operation. So we will have sine of x minus 1 minus sine of x plus 1, like multiplying, because this sine is multiplying this second operation. And at the bottom, sine to the square minus 1. So here we need to get rid of the parentheses. So we multiply this by minus 1 and we will have sine of x minus 1 minus sine of x minus 1. So sine of x minus sine of x equals 0, so we cancel them. And minus 1 equals minus 2. So then we write everything again and it will leave us with minus 2 multiplied, because it is multiplying, 1 over sine to the square minus 1. So here it is a trigonometric identity that we need to apply in order to solve this thing. So the identity says that cosecant to the square equals 1 minus sine to the square. But we do not have this when we have sine to the square minus 1. So it would be minus cosine to the square equals minus 1 plus sine to the square. After we solve this and after we apply this trigonometric identity, we will have minus 2 divided by minus cosine to the square. Then in order to solve this, we will have to apply another trigonometric identity, and that would be the one that says the secant of theta equals 1 divided by the cosine of theta. Then after we apply this trigonometric identity, it will leave us with 2 secant to the square of x. And as you can see, this is the same as the one that we have at the beginning. So the answer is correct.
So now we're going to do a review of the second exercise, which is this one. The first thing that we need to consider is that sin squared is going to be equal to 1 minus cosine squared. Tangent is going to be equal to sine over cosine. Cotangent is going to be equal to cosine over sine. Cosecant is going to be equal to 1 over sine, and secant is going to be equal to 1 over cosine. Okay, so the first thing that we do is that we can notice that since sin squared is going to be equal to 1 minus cosine squared, what we do is that we turn the 1 minus 2 cosine square x into a sine 2x, sine squared x, minus a cosine squared x. Now, the next thing that we do is that we separate the tangent and the cotangent based on this theory, these two theories right over here, into sin over cos x minus cos over sin. The third thing that we do is that we do this little operation, which is we're going to multiply sin squared x minus cosine squared x. We're going to multiply it by 1 and divide it by sin cos x times sin squared x minus cosine squared x. Now this is going to give us an equation more or less like so. This is just rearranging it.